gravitational waves. Gravitational waves. These are typical waves. These are typical waves. Gravitational waves are typical waves. We can't get sense about these gravitational waves because these are so small. Waves on fabric of waves, they are called waves on fabric of space-time. They are called fabric of space-time. What is called typical waves? Gravitational waves means typical waves. They have been called waves on fabric of space-time. And it's a prediction. It was predicted by famous scientist Einstein. Einstein predicted in 1916 about the gravitational waves, and exactly after 1 century, scientists detected these gravitational waves. Why was not detected till 100 years? It's the reason I told you that these are very small, these are very typical waves. It needs very delicate or very sensitive instrument, and as there was no sensitive instrument available to detect it, and that's why it was remained, its structure, its nature was remained unknown to us. But exactly after 100 years we came to know about it, because there was one instrument discovered by the scientist, invented by the scientist, that is LIGO. LIGO is one very sensitive instrument. LIGO meaning is that laser interferometric. I'm writing here laser. L stand for laser, I stand for ferrometric gravitational waves. O stand for observatory. So LIGO is one instrument. By this LIGO, scientists succeeded to detect these gravitational waves. At present we have know about its nature, its properties, etc. But it became possible because of instrument LIGO. LIGO stand for L stand for laser, I stand for interferometric, G stand for gravitational waves, and O stand for observatory. Okay, any problem? If you don't have problem, then again we are going to study about one of the point, that is mass and weight. We will see what is the difference between mass and this point is very important. Question can be asked in exam. Define mass or define weight. Or there is another question which is asked a number of times when I was studying. That time also question came in board exam, that differentiate between mass and weight. So what is meant by mass? Mass means what? I am going to tell you that mass means total amount of matter. Mass means total amount of matter. Total amount of matter contained in matter or object. Sorry, not matter, object. Total amount of matter contained in object is called mass. Yes, total amount of. Means, for example, suppose you have 200 pages notebook. Means 1, 2, 3, 4 you counted, it remains 200 only. If you go in America, if you go anywhere, even if you go on any other planet, what will happen? 200 pages means 200 pages, same that 200 pages number will remain constant. Means mass does not change at all. Mass does not change. Mass does not change according to place and height. If you go in America, if notebook is made by 200 pages, That notebook is taken in America, that notebook is taken in Australia, that notebook is taken in Canada, or even in England or anywhere like a cricket tour, then its pages will remain same. Means if in cricket 11 players are playing, 11 players will play. So like that 200 pages notebook means 200 pages will remain anywhere at any height at any place. So mass does not change according to place and height. Second thing is that mass is scalar quantity. Mass is scalar quantity. Mass is scalar quantity. It's a unit. It is measured in kg. It is measured in kg. Now, what about then weight? We have to study about weight. So, mass, any matter, any object is there. On this object, gravitational force acting on it. Even I was telling to you about notebook. Then any object on it, gravitational force is acting on it. So force exerted by force acting on any object is called weight of that object. Force acting on the body, gravitational force, not only force. Here we should take gravitational force. Gravitational force acting on the body or object is known as weight of that object. So gravitational force is acting on the object or gravitational force is acting on the body. It means that direction is required. Because force comes means direction is necessary. So for this weight is vector quantity. But before of it, this gravitational force acting on the body, that is called a weight. The value of gravitational force, value of G is different at different place. According to height it is changes. According to if we go inside deep, it will change. Means weight is never constant. So here next point for difference is that value of weight changes. Weight changes according to height and place. Height and place. Then force is acting means it is vector quantity, means direction is most important thing. So weight is a vector quantity. And it is force, weight, unit of force is Newton. So force acting on the body is called a weight. Therefore its unit is Newton. So 4 points are becoming. If you write these 4 points, then you will get 2 marks. So F is equal to mg. How it is calculated? Force is calculated. Force F is equal to mg, means product of mass into gravitational force. Gravitational force acting on the body, that is called a weight. So one more time we will check it. That mass means what? Total amount of matter contained in it. Total amount of matter contained in it. That is called a mass. And weight means what? Gravitational force acting on any body is called weight. Mass does not change anywhere according to place, height, but weight changes according to place, height. Mass is a scalar quantity, weight is a vector quantity, and unit of mass is kg, unit of weight is measured in Newton. Dear students, if you understand, then we will go in next point, but don't forget to subscribe this channel. Now we are taking next one, that is free fall. Free fall. What is meant by free fall? Now here this duster is in my hand. I hold this duster. This duster is not falling. Why does this duster not fall down. What is the reason? Though gravitational force is acting on it, now duster is holding in my hand, means gravitational force is acting on it, then if gravitational force is acting on it, then anyhow this duster should fall down towards the center of the earth, but this duster is not falling down. Its reason is that my hand is there, my muscular force is also acting on this duster in upward direction. Gravitational force acting on this duster, pulling towards the earth, pulling towards the center of the earth, means this duster is trying to come down, but it is get stopped. Its reason is that buoyant force is applied by my hand. My hand means my muscular force is vertically acting on this duster in upward direction, therefore it is not falling down. But if I release this, if I release the hand, then what will happen? This duster is fallen down. Means when there is no force applied rather than gravitational force, when there is no external force applied on the body rather than gravitational force, then that body will fall down. This is called a free fall. Means when there is, now why is free fall taken? Why is there free fall? Because if there is no other external force, when this body comes down, when this body is falling down towards the center of the earth, it is get opposed by the air. Air resists the motion of the earth, but that frictional force or resistance of the earth is very rare, very small, and therefore this body falls down. This is called a free fall. And free fall is taken place everywhere because those objects are trying. Suppose if I throw stone upward, stone will reach, or this duster if thrown vertically upward, it will reach at a certain height, and from there onwards again it comes down because of gravitational force exerted on it. It comes down because of gravitational pull. Then however it comes down, it will come with a velocity. However it comes down towards the earth, its velocity will increase. But if you want to see the exact free fall, then here there is need that we should have to observe exact free fall in vacuum, and it was observed by the scientists. It's one film, one clip is available on YouTube. You may see that what is explained in it, or even in 1500, I think 1560, Galileo has observed a free fall. Mass does not matter. Though suppose weight of this duster is 1000 kilogram and a small feather which is light in weight, when they are released at a certain height in a vacuum, both will fall at the same time with same speed. Means mass is not the matter for its free fall. Understand what I told? So pure free fall is observed in vacuum, not in air, because air exerts its resistance force on it, and that's why some changes can take place. Heavy object with greater mass can come with more speed, and object with light in weight takes a lot of time. About free fall. So in case of the free fall, this velocity is when object falls from certain distance, its velocity as it comes towards the earth, its velocity increases. Suppose here one body with 100 kg, what will be its velocity? And there is another one object with only 1 gram, what will be its velocity? How much time will it take to reach on the surface of the earth? That can be calculated by Newton's laws of motion. So initial velocity is always 0. G value we are knowing that g is equal to 9.8 and t time, what is the time, or v be the final speed, that we can calculate it by different laws of motions according to different laws of motion. Which are the laws of motions? One is equal to v is gt, or second law of motion is s is equal to half gt square, or third law of Newton's third law of motion is equal to v square is equal to 2gs. These are the three different laws. With the help of these three different laws, we can calculate the velocity of the object reaching towards the earth and time taken by the object to reach at the ground, to reach on the earth's surface, is calculated by v is equal to gt, s is equal to half gt square, or v square is equal to gs. These three laws of motions are useful to calculate velocity and reaching time after free fall. Now here we are going to study about gravitational potential energy. Gravitational potential energy. Before looking gravitational potential energy, we should have to think gravitational potential energy. Here, satellites or moon rotating around the earth under the gravitational field of earth, then also they are not falling down. Means any object is thrown vertically upward direction, it comes down. Apple which was fallen down from the tree came towards the earth. If someone comes and throws to us in upward direction, again we will come down. Then why planets or why satellites do not come towards the earth? Why moon do not fall? Why moon does not fall towards the earth? It's the reason. What is the exact reason? So its the reason is simple, that it is depend upon mass. So mass of earth, mass of apple has a lot of difference. Therefore, the force of apple, force exerted by earth on the apple is greater than the force exerted by apple on the earth. Means earth is exerting force on the apple, apple is also exerting its force on the earth, but as the mass of apple is small, therefore apple is get attracted towards the earth, earth is not attracted towards the apple. But here, now just what I was telling to you, that then though moon or satellites are moving in a circle in the field of or under the influence of the gravitational force of the earth, they do not fall down. Its the reason is that their own motion. They have motion. Because of their own motion, they are not get attracted towards the earth. That is the. We are going to see next point. What is meant by gravitational potential energy? You have studied the definition of potential energy. Potential energy means what? Who can tell? Potential energy means energy possessed by the body on account of its position of rest. If object is at rest, if here duster is at rest, means duster has energy, this blackboard has energy, this board has energy, or each and everything, every object have energy on account of its rest position. That is called a potential energy. I will write here definition of potential energy. Energy energy possessed by body on account of its position of rest, and potential energy is calculated by mgh. M stand for mass, G stand for gravitational force exerted by Earth, and H is height. Then now here, suppose there is one object at a certain height. One object is at certain height from the Earth's surface. Then its potential energy of this object at a certain height is calculated by the formula MPE is equal to mgh. Then this h, if h is considered, value of h is considerable, means even though it is 8.8, means it is equal to the distance of the height of the Mount Everest, then also it does not matter more. But if this value of h is unlimited, means beyond the capacity of the gravitational force exerted by the Earth, then that is always lesser. Means at a certain distance, at unlimited distance, at infinite distance, gravitational force does not act on it. So at a certain height, PE, potential energy, is equal to mgh, and when body goes in upward direction, value of g is always taken negative. Therefore, when object falls down from a certain height, it is calculated, or its potential energy is negative minus g capital M small m upon r plus h, means the radius of the earth, and h means distance from which object is falling down. Then this is negative, means it is less than zero, but if object is at infinite distance, potential energy remains zero. Then here this concept is used for giving up the satellites in the sky. So we are going to study about what is meant by escape velocity. We will study about escape velocity. What is meant by escape velocity? When we throw any object in upward direction, at last it has one limit, because gravitational force acting on any object which is thrown in upward direction. So greater the initial force, then at a greater distance object will reach. But if initial force is less, initial velocity is less, it will not reach at a maximum distance. Means greater the initial speed, greater the distance covered by the object. It is a simple thing. Why then initial speed is though greater, then also that objects are coming down? Its reason is that gravitational force acting on it, however body goes at a certain limit, then its speed decreases, its velocity decreases because of gravitational force, and at last from a certain height it comes downward, and therefore anything which is thrown in upward direction does not reach at a unlimited distance, does not go permanently in upward direction, it comes down. But if we want to send any object permanently in the sky, then there is need that greatest initial speed is required, greatest force must be used, that is called escape velocity. Escape velocity. So force Escape velocity means what? Force exerted on object to get maximum initial speed to overcome the gravitational pull of Earth. That is called escape velocity. Look here, force exerted on object to get maximum initial speed or maximum initial velocity to overcome gravitational pull. That initial velocity is called escape velocity. We see, if I want to go beyond the gravitational pull, then I must have greatest initial velocity. I must have such a force, means to get the maximum velocity, means velocity which overcomes. In short also we can write initial velocity which helps to overcome the gravitational pull of Earth is called escape velocity. And this escape velocity is calculated at two places. One is on the surface of the Earth, and one is at infinite distance. It is calculated by the formula v square is equal to u square plus 2as. This Newton's law is used here to calculate the escape velocity, and here on the surface it is escape velocity is calculated on two places. One is on the surface of the Earth, and second one is that at infinity. So we will check it that how. First is that kinetic energy on the Earth's surface. It is 1/2 mv square formula is used, and potential energy, to calculate potential energy, minus gmm upon r. This formula is used, and thus then because of this formula, then here total energy on the surface of the Earth is equal to Ke plus Pa. What is Ke? Ke means half mv square plus here in bracket minus gmm upon r, that is 1/2 mv square minus gmm upon r. This is the formula to calculate the escape velocity on the surface. And at infinity, it is different one, that Ke, when it reaches at an infinite distance, then Ke means half mv square. It becomes zero, and Pe is equal to also becomes zero, and thus then escape velocity on at infinite distance is becoming that Ke total energy at infinity is equal to Ke plus Pe, that is both are 0 plus minus gmm upon infinity, both are becoming 0, and thus by this way escape velocity is calculated Here I have tried to explain all these points properly. This lesson is very simple. It has some numericals. There is need to make one more special video to solve the numericals. After making it, I will send it. To get the video related to numericals, you must subscribe this channel. You should read this lesson again and again. You should focus on laws of motion, Kepler's law, gravitational law of universal gravitational law. We should focus on distinguish between mass and weight. Besides that, you should focus on the definitions. What is meant by escape velocity? What is acceleration due to gravity? You should do these all small things. Repeat again and again. Learn, remember and write. 3R. Read, remember and write, which will make you perfect. I hope that you will study it properly and you will get all out marks from this lesson. Thanks for watching this video. Once again, requesting you to subscribe English Medium Academy's channel. Thank you.